Welcome you all to this lecture 9.3. This is on transformer no load test. This test is done to basically find the transformer parameters and some constants. And before that, in the earlier lecture, in the lecture 9.2, we have talked about a practical transformer on no load condition. And we derived the phasor diagram here. This is the ideal transformer. This is the practical transformer phasor diagram. And what we derived this two type of current, magnetizing current and working current or active current component. And this cos phi we developed, that is no load power factor. This one is the no load power factor we derived in the last class. Now this is theoretically development. Now we'll see that how we can do simple transformer test to determine the different transformer parameters. Different transformer parameters means its core losses, copper loss, iron loss, and other parameters constants like the winding resistance referred to primary, secondary, no load power factor, etc. So how we can do this? We generally do two type of test. Two tests are performed on transformer. One is known as no load test, that we will be discussing today, no load test, and another one is short circuit test. Short circuit test, and this no load test is also known as open circuit test. Open circuit test. These two tests combinedly determines all the parameters required for actually understanding the voltage regulation and efficiency and everything. So we have already discussed in lecture 9.1 regarding the efficiency, and there we have seen that for calculating the efficiency, actually we need the no load the copper losses, actually copper loss for on load copper loss, at rated load copper loss, and the constant losses, that is iron loss or coal loss. Both losses are required, and this no load test is performed to identify the core losses, to calculate the core losses and no load current and no load power factor, etc. And this short circuit test is used to determine the full load when rated current flows in the secondary, then the copper losses. So this will be discussed in a separate video. For the time being, let's discuss on the no load test. We focus this for no load test. Basically the theoretical development or theoretical calculation is all this, but now we'll see that what will be the circuit diagram to for performing this test. Suppose this is the transformer, this is the transformer primary side, and this is secondary side. Now to perform this no load test or open circuit test, why it is open circuit? Because we keep the secondary open. This part is open circuit, that is we do not connect any load there. So basically we are doing that secondary current is zero. And one important thing to remember is that we do this no load test strictly on the low voltage side. And no load test is done on low voltage side. We treat this low voltage side as primary, and we perform this test on this side. And in the high voltage side, this is basically high voltage side, this side is the HV side. On the high voltage side we keep open, so no load is connected. So the high voltage side is kept open circuited, and low voltage side is we are performing the test on the low voltage side. Now for performing the test, what basically we need the power consumed. If we see here that we in the earlier development, what we say that all the power consumed when a practical transformer is working on no load, the whole power consumption that will be consumed from input, that is basically nothing but the iron or coal losses. So basically what we need the what amount of power is consumed in the primary for no load test, and what we need also this value, what amount of current it has drawn from the supply, and what is the voltage of the supply. So for that purpose, suppose what we need, we first need to know the current. So to measure the current, we need to connect an ammeter, AC ammeter on the series. So ammeter is connected in this way. This will measure the primary no load current. No load current is, we already written here, that no load current is denoted by I0. So no load current will be, we can get the no load current from the ammeter. Now we also need one voltmeter. Suppose this is the supply. Here we are giving the supply, suppose. So to measure the supply voltage, we also need to connect a voltmeter. Voltmeter is connected in parallel. So this is a voltmeter. So this voltmeter will measure the supply voltage. That is, we can say V1. This voltage will be measured by this voltmeter. Now what we add, another thing we need, that is a wattmeter. This wattmeter will measure the input power. So let's connect an wattmeter also. So this is the wattmeter. So let's say basically this is the wattmeter connection. So now we have this wattmeter reading is, suppose W0, no load wattage, the no load power drawn by the circuit. This voltage this rating is V1 and this is I0. So now we have everything we need for calculating the core loss or iron loss. First of all, here we see this here, iron loss. We already know iron loss or core loss, because copper loss is very small. Why? Because copper loss is in this case very small, because this current amount I0, we have already told I0 is almost 2% to 5%, maximum 10% of rated current. So it is very small. So in that case, if I0 is very small, then I square R is also very small. I0 square R 1, that is the primary side copper loss, will be very small. It is very small with respect to the core losses. That is iron core losses means hysteresis and eddy current loss. With respect to that loss, this is very small. And this voltage, also remember, this voltage V1 is, we apply the rated voltage. This is not any small voltage. This V1 is basically rated voltage. So what is rated voltage? If this transformer is supposed to work with suppose this transformer is 220 volt by suppose 880 volt. So that means this primary side is given 220 volt and secondary is kept open. And when 220 volt is given, then the current will flow, and this current will do what? This current will go through the primary coil, and this coil will generate the phi, that is the magnetic flux. So, and it will also supply for the hysteresis and eddy current loss and very small amount of copper loss in the primary winding. So for the time being, actually we are ignoring the copper loss, as this loss amount will be very less. So in that case, whatever we get in the wattmeter reading, that wattmeter reading, we call it W0. This is nothing but this is the coal loss or iron loss. We call it as PI. And we also know that this coal loss or iron loss does not depend on the other factors. Like these losses are also known as constant losses. So this loss remains same without depend on the current. So this, when the transformer will be fully loaded in actual case, then also this coal losses will be same. So we easily measure the coal losses in terms of wattmeter reading. That is, this is the wattmeter reading. So wattmeter reading gives us the power consumed, that is the coal losses or constant losses for the transformer. Now similarly, also this W0 is nothing but V1 into I0 cos phi. Cos phi is cos phi 0. So also from here we also know the V1. V1 is also we are getting from the voltmeter. I0 we are getting the no load current drawn from the emitter. So and W0 we also know. So from there we can easily determine the value of cos phi 0. That will be W0 divided by V1 into I0. This is the no load power factor. No load power factor. So this also can be determined from this test. And one more thing we can determine from the test, that is these two current IW and IM. How? Because as we already got the cos phi 0, so actually I0 cos phi 0 is the IW workable current component, active current component, that is basically I0 cos phi 0. So that is basically nothing but W by V1. So this is W by V1. So already we know W and we know V1. So W by V1 we get IW, and IM is I0 sin phi 0. So as we know cos phi 0, then we can also find sin phi 0 value also. So actually using this test we can actually have the from the wattmeter reading we get the core loss or constant losses and no load power factor, also magnetizing current and workable current or active current. So now in the from the short circuit test actually we will get the when rated current will flow and what will be the copper losses. That copper loss actually varies with the current, so that has to we have to flow the rated current to measure the copper loss. So when we'll see the short circuit test, then we'll know that part, and combining those all the parameters, combining these two tests, we will have all the parameters from which we can actually calculate the efficiency and voltage regulation for a transformer. Thank you.